This is cavity slide. As you can see, it is not plain. It is having a kind of cavity here and also here. So on this cavity, the drop will be hanging, and where we will put this drop? On cover slip. And through cover slip we will bind it. How? By using wax at the four corners of this cavity slide. So let's start with the motility of bacteria. So this is cavity slide and that's cover slip. We will put the wax on the four corners of this cavity. Putting the wax. Make sure you are doing hanging drop at the corner. Why? Now I will tell you. Take the inoculating needle. Now remember, for the motility, you need to use just a drop of culture. A single drop of culture consists of at the most bacteria that you can visualize through microscope, and it is containing that much bacteria equal to the humans present on earth. So let's start. Take the culture. Just a drop. See the single drop like a dot. Sterilize the loop. It's red hot. Keep it aside. The slide is with wax. Put it upside down. Cavity is present here where I put the wax. So here it is plain area. This is our slide. Put it over there and immediately lift it. See the drop hanging in a cavity slide. So we have learned how to use microscope. This is specialized video microscope. We have prepared a motility slide, and on 10x you need to make in the movement of the slide in such a way that you can at least look at the margin of the drop. See, we have prepared motility slide where we can see the motility of bacteria by hanging drop method. So first we need to locate the margin of the drop. Obviously for aerobic bacteria they show the motility near the air, means at the margin. For anaerobic bacteria, we usually locate the center of the drop. So here you can see at the 10x margin has been located, but remember, you cannot completely visualize the motility of any bacteria. These dot 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 like structures are nothing but bacteria. So as soon as we have located our 10x, we will shift simply on 40x without any disturbance to the slide. See, now you can see some kind of movement. Now I will go for fine adjustment where you can locate different kind of bacteria. See, I have inoculated E. coli. So that's E. coli culture. They show sluggish motility. Sluggish means slow motility. You can see at the margin. They are cocobacilli, so we cannot tell it as a cocci or bacilli. As soon as we focus through fine adjustment, we can see the different layers of the drop. So a single drop, the margin consisting of numerous bacteria which are present in class. So I have told you, this is the portion of margin. What will happen if we go on looking inside the drop? See, that was sluggish motility. Their E. coli is facultative anaerobe. You can see they are not moving so much because they don't require oxygen. Again movement, again movement, again movement, coming to another margin of the drop. Again sluggish motility. So this is the way we observe the motility of bacteria and record it accordingly. Some bacteria, they do not move at all. Some with sluggish motility, Brownian movement, there is random movement shown by few bacteria. Some are fast moving in a so much rapid way that you are unable to locate them. Sometimes we can even observe the morphology of bacteria. Here we can see they are not cocci, they are not bacilli, that's cocobacilli. See, different levels of bacteria at different planes of the drop. And at the margin, see the sluggish motility. So this ends with the motility. We never go for 100x because at 100x is also known as oil immersion. We put the oil for better resolution, but as soon as that touches to the cover slip may break. So we record motility only at the 40x. This ends with the motility of bacteria.